Thanks for the invitation to present. As Colin says, my background is in cancer biology, but not that much lately. So I'll give a bit more of a highlights of what we do at Ersilia and our way of working and thinking of doing research in a different setting. So I hope you can see my screen. Perfect. So Ersilia is a tech nonprofit, small tech nonprofit that works to reduce inequality in global health. We are based off Spain and United Kingdom, and our mission is to equip laboratories in low-income countries with AI tools to support infectious disease research. At the current stage, we focus on drug discovery. So why do we work on that? Well, you are all familiar with this map. I guess that's the world, each country depicted by its land and associated to its level of income according to the World Bank. So what happens when instead of depicting the land area, we depict the communicable diseases? We can clearly see how those, we all know that, but it's good to see, remember the numbers from time to time. They really affect disproportionately low and middle income countries, particularly those in Africa. And on the contrary, when we try to plot the scientific production, we see how those countries are actually the ones that contribute the least to the scientific outcome of the world. And just to put some numbers, 6 of the top 10 causes of death in those countries are still infectious diseases. They produce quite less than 5% of the world research. And therefore, there is a huge imbalance in biomedical research and global health that leads to a very few number of drugs being developed for infectious diseases, including COVID. So with these numbers, what can we do as a small organization? Our goal is to help bridge this gap using artificial intelligence. Why? Because it's cost effective, it's faster to implement than experimental research. It's data-driven, meaning we can use data that is already out there that has been produced, and also data that has been developed in other contexts, mostly non-communicable diseases, for which there is more funding and data. And we can reuse existing methods that also have been developed mostly in the field of non-communicable diseases. And it's a growing field that certainly has the potential to revolutionize science for low resource settings. So with that in mind, our organization work is based on 3 pillars. The first is that everything we do is free and open source. Our code is made public real time. Everything is associated to open source licenses. It can be used either by commercial or non-commercial purposes. And when we collaborate, we don't claim rights on patents on anything that has been discovered with our tools. These remain within our collaborators, mostly in the Global South. We support in-country research, meaning that we look for projects that are led by local institutes in the Global South, mostly in Africa. And we focus on in-situ implementation, meaning that if it's needed, we travel to our collaborators, spend time there, and really try to make them start their journey into data science and AI. And the third is that we focus on sustainable collaboration. So everything we do comes together with capacity building, with training local scientists, finding champions that can continue the work after we are gone, and basically develop AI with low computational resources, so not these big models that require supercomputing power to be developed. So Ersilia's toolbox has 3 parts. The first is we provide AI models as ready to use for scientists. We also provide a way of building these AI models in an automated manner. And now we are focusing on trying to help those scientists expand the chemical space using inspiration from natural products and so on. So I'm going to give a highlight of these 3 different major tools that we are developing at Ersilia. So the first is the Ersilia Model Hub, which is basically a collection of ready-to-use models, meaning that the scientist, the end researcher, which is usually a lab researcher like I was myself one day, doesn't need to understand or know the steps that happen inside building a proper AI model to predict, for example, the target of a given potential drug. But they can simply interact with the models through this layer of deployment and get the output. So the Ersilia Model Hub serves this kind of models. We have models that are already in the literature. We just bundle them and incorporate them in the hub because we know that open source models tend to be published and many times not maintained by the original authors. So we take those models, we incorporate them in the hub so everyone can use them, of course, citing the original authors. We take data from the literature, from large screenings that are out there, like this very large anti-malarial screening. We build models with those on a regular basis and deploy them in our hub. And most importantly, we work in collaboration with institutions in the Global South, and we try to understand their needs and produce models based on their data or with the public data that support their research needs, like we do at the University of Buea. This is how our interface looks today. We have over 100 models, and this keeps constantly growing. We have built this, of course, not alone, but in a very much open source effort where we have a lot of contributors from everywhere, but particularly from underrepresented students in STEM. We have all this nice workflow that is based off GitHub that you can go out and check out. We do have the support of tech companies like GitHub and Atlassian and so on that have helped us, let's say, professionalize our tool behind the normal academic deployment, going a bit farther and trying to do something that is a bit more professional and easier to use. So this is the first of our tools, which is to simply make models, AI models, available to scientists who are not data scientists and won't be experimental, won't be computer scientists, but are rather experimental, but want to use these tools. We have been piloting this approach, for example, at this very beautiful center that is being built at the University of Buea in Cameroon. This is Mount Cameroon here. This is how the building looks as of September, when I last was there. They are starting antiviral drug discovery from African natural products. They have a large database. They need to filter it out because their experimental capacity is quite limited. This is a project funded by the Gates Foundation. It also collaborates with the Wistar Institute in the US, and it has all these different pillars. So starting from these natural products, but also synthesis of molecules, bioassays, and of course, all the data science part. So we are contributing to helping this center get started. Our second tool, which is to build AI models. So we realize people want to build their own AI models, so they need automated tools to do so. So we have been piloting this approach. This is another mountain, if you recognize it, that's Table Mountain in Cape Town. This is the University of Cape Town, where we are working together with the H3D Center, which is a small drug discovery center that does anti-malaria and anti-tuberculosis drug discovery. They did have a lot of in-house data, but they didn't have any AI expertise. So we partnered with them. We developed a cascade that basically mimics their experimental setup. We have implemented it using their data, but also open data sets, and now it's helping those scientists find malaria and tuberculosis drugs. This pipeline has been just published the last month, so I invite you all to check the paper, which I'm not discussing for time constraints. And then the last one, something that we are very actively developing at this moment, is on generative AI, of finding new molecules. We did have a first initial project with the open source anti-malaria consortia, which is looking for new anti-malarial candidates against falciparum. So they did have a good data set to start with, but they wanted to optimize the activity. So we generated new candidates, and we tested, these are the candidates that are being generated by the AI. The bluer the color it turns, the more active it's predicted to be. So we selected the best 8 candidates that we could find, and we tested in the lab, and 4 of them, so 50%, that's an extremely high rate, had very good in vitro activities against Plasmodium. So we are very, very excited by these preliminary results. I'm gonna continue the work on that. So these are our 3 pillars. We do not only do this, we also participate in other projects as part of our nonprofit. Just to highlight a couple of them, we are very interested in understanding the diversity, particularly genetic diversity of African populations, which is higher than other areas in the world. Again, with the H3 Center, we are trying to understand whether drug dosages could be optimized for those particular ethnicities. We do that using AI to predict pharmacogenes and coupling this to PBPK models. And this is a project supported by a consortium from GSK, Novartis, and the South African MRC. Another thing that we do, as I said, is capacity building and training. So we aim to provide in-person workshops at least once a year at the collaborator institutions. In 2022, we did a course thanks to the Wellcome Trust and in Cape Town. This year we were in Cameroon with our collaborators there, and we are already planning for 2024. So hopefully we are able to sustain these more in-person 2-week-long courses for local scientists. And so that's it. It's late for me. It's my Friday evening, so I didn't want to give you all too late. I just wanted to summarize our name because I think it reflects quite well what we are trying to achieve. Ersilia is the name of a city described in this book, Invisible Cities, that is a book by Italian author Italo Calvino. And basically, the city of Ersilia is an imaginary city where its inhabitants throw threats to each other every time they establish a new relation, until the city is so thick with threats that you can no longer pass. In that moment, they leave the city, leaving just the network they have established and build it anew somewhere else. So this is a bit of an analogy of the network of scientists that we are aiming to create worldwide. So that was a very quick sneak peek of who we are, but basically we are a nonprofit organization. We develop AI tools for drug discovery and global health. We combine remote work and on-site implementation at our partner organizations. We do a lot of capacity building as well. Everything we do is open source. We offer support to research institutes located anywhere in the global south, and we are always open to collaborations. So thank you to all our amazing team and supporters and donors and collaborators. We really have a lot of people to thank you for these last 3 years of Ersilia. And of course, thanks all for the opportunity to present here. And I'm happy to take any questions.